Hello, welcome. Today I want to show how to measure the latency of a real-time system. In this case we use RTAI, and it stands for Real-Time Application Interface. This is RTAI web address. It is a real-time extension that runs on Linux operating system. And here is the most recent release. Now, what does latency mean? Latency is a time interval between the stimulation and response, or in other words, is the time delay between the cause and the effect. Latency is one of the most important features of real-time systems. In this test we use a desktop computer with RTAI installed. We apply an interrupt signal to parallel port. The interrupt signal is connected to pin number 10 and the response to pin number 2. With an oscilloscope we display the input and output signals, and it measures the difference between them. When an interrupt occurs, the CPU stops the running code and executes the interrupt service routine. When this routine finishes its execution, the CPU continues with the program that was executing before. We can find API information in this address. Here we have modules, functions implemented by RTAI. We can select any of them and get a brief description, parameters and the value that this function returns. To implement the interrupt service routine, we will program a module. A module is an object code that we can insert in and remove from the kernel in running time. The preferred language to program modules is C language. Okay, let's start creating latency module. We have to include module and init kernel headers. Each kernel module has an entry point and an exit point. Let's start with the entry point. This function is static and returns an integer value. We add the init marker and the function name is insert module. This function is invoked when the module is loaded. Now let's continue with exit point. It is also a static function. It does not return any value. We add the exit marker and remove module is the function name. And this function is called when the module is removed. Lastly, we include two macros. These are mandatory to indicate which function must be called to initialize a module and which to exit. Let's compile latency module. We create a makefile. We have to use obj-m variable and assign latency.o to it. To compile modules, we need to have a kernel built. We assign the kernel source tree to this variable. This is our current directory. All target and the procedure to compile modules. Clean target and its procedure. We save the file and compile. There are no errors. And here is the compiled module. Latency.ko. To load modules we use the insmod command. And we need to have root privileges. lsmod command prints loaded modules. And here is latency module. Finally, this command is to remove modules. Let's continue programming latency module. We include RTAI header, RT request installs a function to handle the real-time interrupt service routine. It needs two parameters, the interrupt number and the interrupt handler function. To find out the parallel port interrupt number, print interrupts file inside proc file system. The interrupt number assigned to parallel port is 7. We use define macros to create constants. We add the interrupt service routine function. On success, this function returns 0. To the contrary, it returns this value. Now let's configure parallel port. There are 3 registers: data, status, and control register. Each of these registers has an address. Base address corresponds to data register. Base address +2 corresponds to control register. To enable interrupts, we have to set bit 4. Let's take a look to EOPorts file. This is the parallel port address in hexadecimal. We assign this address to base port. OutB function configures parallel port, writing this value to control register. RT enable function enables interrupts, in this case from parallel port. Now let's go to the interrupt service routine function. When the interrupt arrives, we write 1 to data port. We hold this value for many cycles. Then we write 0 to data port. These 3 statements generate a pulse. This function allows to interrupt the CPU again. Now, when the module is removed, we write 0 to clean data port. This statement disables the interrupt from parallel port. Finally, this function uninstalls the interrupt service routine. The module license is GPL. To compile, we have to include the path to RTAI headers. Save and compile. There are no errors. Don't worry about these warnings. Here is latency module. First, we have to load HAL module. Now we can load latency module. This is the interrupt signal. Its frequency is 1 kHz. The interrupt occurs in the rising edge. Now let's load latency module. Here is the signal generated by interrupt service routine. It looks stable and predictable. Now let's measure latency. As you can see, latency is not constant. There is a jitter. Hardware and software are the cause of jitter. Time scale is 1 microsecond per division. To the naked eye, latency is around 10 microseconds. It is consistent with other tests reported. In fact, latencies reported are average values. This test gives us a first approximation to measure interrupt latency. The characteristics of the system are the following. RTAI version is 3.7.1, and this is the kernel version. And the computer is a Pentium 4 at 2.8 GHz and 1 GB of RAM memory. The source code is available in this link. Thanks for watching this video.